Hello, my name is Tammy Miller. In this carboxyl derivatives video, we're going to name esters. To name esters, there are some very specific points that we need to follow. First, we need to treat the carboxylate portion of the ester as the parent chain. And remember, the carboxylate portion is the portion that's going to contain that carbonyl. Then we will treat the alkyl chain. This is the portion without the carbonyl that is bound to that carboxylate as the substituent. We will name the parent chain as you would any carboxylic acid. But what we're going to do is we are going to replace the oic acid with the suffix -ate. We're going to name the alkyl chain using the suffix YL and place this portion of the name in front of it. Let's take a look at 4 examples. In our first example, we want to name the following molecule. And the first thing we want to do is look at the alkyl portion, the portion that does not have the carbonyl carbon on it. And this is the portion on the right. So we see 1, 2, 3 carbons. This is going to make a propyl group. And remember, we put that YL on the end. Next, we are going to take a look at the carboxylate portion. And the carbonyl carbon will always be the lowest numbered carbon. So I'm going to start with that as carbon 1, 2, and 3. So there are 3 carbons here, making it a prop group. And this is going to be originally propanoic acid. But remember, we cross out the oic acid and we add an -ate. So the final name for this molecule is propyl propanoate. Let's try question B. Question B, we're going to work with the alkyl portion first, and we're going to look for the longest carbon chain. Here we have carbon 1, 2, 3, and 4, which makes it a butyl group. And we need to notice that there are 2 methyls that are coming off of this butyl group. And they're coming off of carbon 2 and carbon 3. This will give us a 2,3-dimethyl butyl substituent. Now we're going to look at the carboxylate. And again, we're going to start with our carbonyl carbon as carbon 1. So this is going to be carbon 1, 2, 3, 4, and 5. This is going to give us a pent group. And we are going to have the alkene on the second carbon. So this is going to be a pent-2-ene. What we now have is a pent-2-ene oic acid. We need to determine on this carbon-carbon double bond what direction we have our substituents. We have one of the substituents coming off this direction and one of these substituents coming off this direction. Since they are on opposite sides of the double bond, this will be an E or opposite. So we need to note that this is going to be an E2,3-dimethylbutyl pent-2-enoic acid. Now, remember that we get rid of our oic acid and make this an -ate. The pent-2-enoate is very, very formal. By IUPAC nomenclature, we could also call this E2,3-dimethylbutyl 2-pentenoate. We still know that that 2, since it's before the pentene, is telling us where the carbon-carbon double bond is. Let's look at our third molecule. For our third molecule, again, we will start with our alkyl group. And we have 1, 2, 3, 4, 5, 6 carbons. So I know that this is going to be a hexanyl. And off of the third carbon, again, here, I have this methyl group. There's a methyl group and a carbon-carbon double bond on that third carbon. So I'm going to get 3-methyl, 3-hexenyl. Next, I'm going to move to my carboxylate portion. 1, 2, 3, 4, 5, 6 carbons. Off of this, I have 1, 2 methyl groups that are going to be on the 4th and 5th carbon. So this is going to be 4, 5 dimethyl hexane. This time I'm going to skip putting the oic acid and crossing it out, and I'm just going to go with hexane O8. So this is 3-methyl, 3-hexenyl, 4, 5 dimethyl hexanoate. For our final piece, we're going to start with our alkyl portion. I have 1, 2 carbons, which makes this an ethyl group. And I have a chlorine off of the first carbon. So this is going to be a 1-chloroethyl group. Next, I'm going to look at my carboxylate portion. 1, 2, 3, 4, 5, 6, and 7 carbons. This is going to be a heptene because I have a double bond. And I have 2 methyls coming off of this, 1 on the 4th and 1 on the 6th carbon. So this is going to be 4, 6 dimethyl, 4 heptene. Again, I'm going to skip over the oic acid and just say heptanoate. If we want to go for the more formal version, we'll put that 4 right before the ene and make this 1-chloroethyl, 4, 6 dimethyl hept, 4 enoate. Esters are molecules that we see quite often in organic chemistry. It's important that we know, once we have synthesized an ester, how to name that ester.